Chrissy. I'm the Southeast Regional Estimator and the Southeast Product Expert for VFDs, valves, dampers, actuators, and flow stations. So we're going to start with going over some of the safety and wiring practices on our VFDs, do a little bit more on product introductions, and if we have enough time left, we'll do the setup wizard and programming of the VFDs as well. When we're talking about VFDs and installing these devices, I'm going to go over a lot of things that I'm sure is common knowledge to all of you, but you know, we always like to go over things multiple times, especially when they come to safety. Okay, when you're wiring up a VFD, whether it's a replacement or even a new VFD, always verify that the circuits are dead, that they're not live. Verify their condition. Lockout, tagout devices are critical. Read all instructions that come with the drive. I know folks hate reading instructions, but it is important. Even if you've done them before, things change from model to model. Lockout, tagout is critical. If you're required to wear PPG gear, and I highly recommend that you wear all of your personal protective gear, please employ all those items. They're there for a reason. They're there to help you guys stay safe. Re-verify the conditions of your circuits, particularly if you walk away from a device. If you go take a phone call, if you go to lunch, when you come back, never assume the circuit is in the same condition it was in when you left. Very critical. On VFDs, ground is not an option, as it is with all devices, but it's really critical for the proper operation of a VFD. And not only that they be grounded, but they be grounded in the correct ways. There are diagrams inside our instruction sheets that tell you how to ground them, the particular terminals to hook to. We're going to go over some of those during the presentation. So be very careful and very conscientious about how your grounds are handled. If you're asked to go inside the drive to do tests or to do repairs, be sure to either discharge the capacitors manually or allow at least 5 to 10 minutes, depending on the size, for the capacitors to bleed down before you reach inside. They have very high voltage and very uncomfortable to the touch. Some of our larger VFDs have an LED inside mounted across the capacitors that will tell you what their condition is. The smaller ones don't, and you can tell if they don't because there'll be a label printed on the bottom giving you an estimated time that it will take the VFD to bleed down. Terminate all power wiring appropriately and be sure to not over tighten terminals. Okay, all of our VFDs have proper torque in inch-pounds to tell you what the torque ratings are on them. You can see all of that in the drive, so please be careful. You'd be surprised how many drives are returned with broken terminals from over tightening. Okay. Power wiring. When you go to set up our drive, there is a little bit of assembly required. You'll take the covers off the drive and you'll notice that there's a bag of connectors, grommets, things like that. Don't discard that stuff. Okay? The grommets are important because they help protect the wiring on the inputs around the input side of the drive. You'll also receive some grounding cables, grounding straps, and all the lugs and stake-ons necessary to complete the installation. Okay. When you get started, you'll pull the cover off the drive. You'll see that there's a power barrier at the bottom of the drive that pivots out. That helps us separate our low voltage and control wiring from the high voltage terminals that are in the drive. Okay. Once those are removed, again, keep all screws. There are extra screws for all these components included with the drive. Let's go on. You can see here we've got a layout of how the drives are wired in a line drawing. The L side up in the upper left corner is incoming power. The U or T side is outgoing power to the drive. We'll have a little bit better details about where the grounding goes on these drives, but the drive is basically the ground connector between ground source and the motor itself. Again, one other thing I want to add is never ever run control cables in a close proximity to control cables. Obviously never in the same conduits. Make all line connections to circuit breaker drives at the disconnect. Don't go directly to the terminals on the drives. Okay, we've got we'll have a little detail further on that shows where to make these connections to. They are labeled clearly. If you're dealing with a full drive with a bypass, okay, those will also have the same labels to show you where to hook to. Okay, that way we can keep up with the bypass and make sure that we're not going around any other parts of the drive. When you're setting up, please look at the overload ratings on the third contactor and second contactor bypasses. It's entirely possible that because of sizing in drives that we're going to be derating a drive. Okay, the drives, bypass and output contactors come from the factory rated at full amps for the drive, meaning a 10-horse drive has a fixed amperage for safety reasons. If you're putting a 10-horse drive on a 7.5 horsepower motor, which is not uncommon, you will have to change the overload rating on the contactor. One of the features of our new drive is that we now allow you to penetrate for high voltage and low voltage at the top or the bottom. The top plate and bottom plate are removable. One of those plates has the knockouts in it for you. So if you need to enter the drive through the top or the bottom, there's not going to be any more drilling required. No worries about having metal chips falling down in the drive and having to keep all that separated. So it is a nice feature of our new drive. Again, we can connect our input power to the yellow labels. Okay? Those labels are provided with the drive, and we also provide extra labels should something happen to the labels that are with the drive during the installation or construction phase of the project. Okay? This is an example of the different types of overloads we have based on size. Okay, those are the points that we will need to respect if we are derating the drive. Again, it's only necessary to make these changes if there is a mismatch between the motor and the VFD. Again, please, motor amperage and horsepower lower than VFD ratings. This is our typical two-contactor bypass. Okay? Our connection points, bypass contactor B and output contactor O, we're going to be connecting to both of those depending on which type of bypass that we use. Okay? Our typical three-contactor bypass, again, note the blue labeling at the bottom where we're going to connect our motor lead wires. Now we're looking at our open drive, but in this case it's mounted in a dust-proof Type 12 enclosure. Okay, we do have a disconnect switch at the top, so we still have to wire to those drives. So this is going to be a combination of both. You're going to see an input contactor or input circuit breaker at the top where our input power is going to be, but the output power will be connected to the blue labels in the lower bottom underneath the wire barrier. Okay. Again, some other examples. Nice view on the left, keeping everything straightened out, keeping everything isolated well. Typical grounds, okay? On the bypass drives, the grounds are side by side, lower part of the cabinet opposite each other. The only place that they're different than that is on the open drive where they're actually at the top and at the bottom. Again, it's all the same chassis ground and the VFD must be between the two ground sources. Any questions on the basic installation of a drive? Anybody run into any issues with these? Anything you need to ask about wire size, lugs, any other questions about, they're not all that difficult to do. All this information again is contained in the documentation that comes with the drive. So, we're good. These are the 5 different drive families that we have now available to us at JCI. The micro drive on the left, our smallest and most bare bones drive. The open drive, which is a full featured drive but does not have a bypass. It is strictly a VFD only. The enclosed drive can be ordered with 2-contactor or 3-contactor bypass. That particular drive is shipped as a Type 1, but it was certified also as a Type 12. So if you're into a situation where you need to convert, then it's very simple. I believe it's a $40 kit that puts a remote fan and all the door gasketing you need to convert from Type 1 to Type 12 dustproof. It's also a very handy thing to do if you're compelled to start a drive and provide air during the construction phase. Converting them, the select drives to Type 12 will keep all the dust and dirt out of the inside of the drives and off the cooling fans. And if you've worked with a lot of drives, you know the cooling fans are the weak link in these, particularly if you're working in a lot of construction. The second drive from the right is our full-on Type 12 drive. It's also the basis for all of our custom drives. It's the basis for our clean power drives. Our 8-pulse, 12-pulse, 16-pulse, and 18-pulse drives are all built on the Type 12 chassis. And on the far right is the rainproof chassis, the Type 3R chassis. Not a NEMA 4, but a 3R rainproof chassis. The micro drive. Okay, the micro drive, as I said, least expensive drive that we sell. Okay, this is a bare bones drive. Doesn't have anything on board except Modbus to communicate with. There's no logic on board with these drives. It takes a contact closure to start it, a speed reference signal to change speed. You get very basic feedback on these drives, a contact closure, and an output reference voltage for the speed of the drive. Okay, in this configuration, it is an IP20 drive. Okay, what does that mean? It means that these drives don't have conduit connections on them. They're intended to be built into another enclosure, probably something like a control panel for a cooling tower or a pump package. We do offer a IP21 package that goes with these that will have a drip shield for rainproof. I'm sorry, let me rephrase. That will have a drip shield. It is not rainproof, and it will have conduit connections on the bottom. Availability. These come 1/4 through 1.5 horse at 115 volt, single phase input, or 230 volt 3-phase output. So we can convert single phase to 3-phase, as most drives can. That is a straight option for us. 1/4 horse to 3 horse at 230 volt. Again, it's going to be single phase or 3-phase input. Has to be 3-phase output. Okay, we can't use VFDs on single phase motors. Half to 10 horsepower at 480 volt. We have 25 horsepower coming soon. I expect that probably by the end of the summer. Again, 3-phase in, 3-phase out. 575 volts, 1 to 7.5 horsepower, 3-phase in, 3-phase out. On the web is a very nice tool if you want to start playing with VFDs to see how the keypads work. You click on that link at the bottom, and I'll be glad to share this presentation with anyone here. I'll have some business cards. Just email me if you want to see a copy of this, and it also will include that link to how to control these drives and set them up. Okay. The open drive, okay, we're moving away from the micro drive now, and we're going to our full line, or full featured open drive. Again, an open drive is a full featured VFD, has all the logic, PID loops, inputs, outputs, can take multiple signals, and can communicate through BACnet or across our SA bus. Okay. The difference between these and our other drives is there is no bypass with an open drive. Okay, has everything else but the bypass. These are what we call our next-gen drive. The nice thing about these is that they are 100% backwards compatible with the previous or the current generation drive. Same footprint, same wiring, et cetera, et cetera. So it's really a nice upgrade for anyone that's been using our previous drives. On board, we have a number of backups, a number of supported communications protocol. Directly on the drive is BACnet MSTP, Master Slave Token Passing. That's built onto the board. It's included with every VFD that we sell. We have optional communications cards to communicate with Johnson's proprietary SA bus. Our original N2 systems, we have a 485 Modbus on board. We can also speak Ethernet Modbus, TCP, and BACnet IP. Okay. We've gone away from the input line reactor, as a lot of VFD manufacturers have, and we've gone to a straight 5% DC link choke. Very similar characteristics of the two, but it also allows us to get a much more compact package. We have a battery backup real-time clock for the first time. This is the first time we've employed those on JCI drives. Very good feature if you're doing standalone control. It also allows you to look at alarms and store alarms with a date and time stamp rather than just a frequency counter. Inputs and outputs. Okay, 6 digital inputs, 6 digital outputs that are all programmable through the drive. 1 analog input, 2 analog outputs isolated. They're in milliamps. They can also be converted obviously through a shunt resistor to voltage. 3 inputs for a PT100. Why do we have those? A lot of larger motor manufacturers and a lot of customers are insisting that we embed thermistors in the windings of the motors to monitor the temperature of the windings and do a shutdown or a warning based on the temperature of the windings. So that is an onboard feature, doesn't require any additional setup. And it's, the temperature ratings are carried over with the horsepowers of the drive. We have 1 relay and 5 digital inputs. It's an open collector relay, so it's very handy. You can take 24 volts directly from the drive, switch it, and bring it back to it. On board, we went through the communications, BACnet, N2, Modbus. Coming soon will be a Siemens Apogee card. It's available currently for the current generation drive. I expect to see it probably in about 2 months for the next gen drive as well. The new graphical display, okay, wonderful feature that we have now, gives us not only alarms in plain English, but it also gives us up to 9 selectable display functions on the drive. Anything that the drive monitors can be shown. Voltage in, voltage out, horsepower, frequency, RPM, amperage, and they can all be configured by, through the setup wizard as the drive's being programmed. Can be done in 5 different languages. A removable keypad for easy setup. The nice thing about the new keypad is that it allows us to put the programming into the drive, copy the program out to the keypad, and then if you have multiple drives in the building with the same database, you simply go up to the next drive and load, and then swap keypads out, return your original keypad to the drive you started with. A very nice copy and paste feature. Also, we offer a kit to, if you have to remotely mount the drive, if you're working with an overhead unit but they want a display down at the ground, we have a remote mounting kit as well that's available. Active Energy Control is available now for the first time through Johnson Controls. Active Energy allows the drive to monitor the load and monitor the changes in signal and not overdrive the motor beyond any normal characteristics that the drive feels would impede efficiency at the motor. Tremendous energy savings of the drive. The easiest way to explain it would be you're driving a truck with a load, you're coming up to a hill. You know you're anticipating that the truck is going to slow down, so you begin to give it more gas to try and maintain speed. As you start up the hill, you reach a point where you can't push the accelerator any further down to the floor and increase the speed of your vehicle. If any further, you're just wasting gas. It's the same with a drive. It monitors its own RPM. It knows how quickly it can respond based on the load that's on the fan or the pump. And it doesn't overdrive that beyond its limit, because in a motor, if we waste energy, we do 2 things. Obviously, we cost money, but we also, that energy is consumed by heat in the windings of the motor, and we're trying to keep that down. So, Active Energy is automatically set up in the drive. There's nothing that you have to do. It runs directly from the keypad, and it can't. And it, I'm trying to. Oh yeah, it's can't be turned off, and it's available to you at any time. The SA bus. Okay, the SA bus to us is really BACnet. Okay, we monitor these 11 points, which are the most common points that the drive needs to run and the most common items that you're looking for as far as feedback from the drive: start, stop, command, status, speed input, speed output. We now have KWH, as well as speed set points and current modes, whether we're in handoff and auto. IntelliPass drives will allow you to place the drive in bypass remotely and not have to go to the drive in order to put it in bypass itself. How does this drive communicate? Where does it live on our network? Well, it can communicate directly to our controllers through our SA bus. It can communicate directly to our controllers through the N2 protocol, and it can communicate directly through BACnet. So a very, very flexible drive as far as communications go. The enclosed drive, the Type 1, and again, Type 1, Type 12 to us is the same drive, okay? The only difference is gasketing kits and how the fans are mounted. Available in 1 horse to 75 horse, 480 volt, 1 horse to 30 horse in 208, and 1 to 40 horse in 230. Software on board these drives includes an HVAC fan and pump applications with Active Energy Control that we talked about earlier. We have enclosures available is a NEMA 1, NEMA 12 convertible. Key differentiators are ease of installation in the top and bottom that we talked about earlier. The beauty of these drives when you look inside of them is everything is nice and accessible now. If you need to replace a component, we don't have to take the whole drive apart on the wall and try and get inside the thing. They're beautifully laid out and easy to access all components. As you can see, we've got our contactors across the bottom, circuit breaker at the top. All of our keypad displays are available through the back side of the board. Just a really, really well laid out drive that's easy to service. The Type 3R rainproof drive. Okay, 1 horse to 250 horse at 480 volt, 1 to 125 at 208 and 230. Same family of control flexibility that we had in the earlier drives. Key differentiators are the NEMA 3R is available for outdoor applications. We can also build custom drives on the 3R platform, the same as we do on the Type 12 platform. If a heater is available, and I highly recommend heaters for drives over 60 horsepower in the South, please specify that option. It is really a drive saver.
Is that for humidity?
It's really what's for humidity. There's a reason to put them in if you're looking for immediate response of the drive at low temperatures, but typically after about 15 minutes, everything's up to temperature and the drive will respond just as fast as it ever did. But it's really, you know, as you guys like this morning, you know, we woke up and some places in the state we're in the 30s, and we'll probably hit the 70s this afternoon, and then it may be in the 30s again tomorrow morning. Condensation is going to be a real problem in those drives, so please use the heater option wherever you can. That's just a comparison. Okay. Where do we use these things? I mean, obviously we've all seen them applied somewhere in the world. Air handlers, supply fans, return fans, exhaust, combustion fans. They give us a good payback. They're good energy savers. They're good motor savers. You know, today with what soft starters cost and the cost of VFDs coming down, there's really almost no reason not to put a VFD on a motor that would normally require a soft starter. Chill water applications, we're starting to see these on pumps for demand pumping. We're seeing them on chillers for controlling flow. Very, very good devices for those. Easy to install, very cost effective. Okay. Questions so far? Anything on application of drives, setup of drives? Wow. Must be doing good, huh? All right. Well, Robert, you want to cue up the next?
It should be queued up there.
At the bottom. The new drive incorporates a setup wizard, and I'm going to tell you it's one of the easiest drives to program from scratch of any drive out there on the market. If it's the first time the drive's being powered up, it will automatically go to the setup wizard for you. If it's already been powered up for testing, rotation, things like that, you can get back into the startup wizard by holding the stop reset button, the red one in the lower left corner, for 5 seconds. And then a message will be displayed if you need the startup wizard, power fail the drive, and it will be available to you when you go back and do the next setup. Okay. In the startup wizard, it's going to say, would you like to enter the startup wizard? Well, yeah, that's why we're here. So we go ahead and select yes through the up and down arrow key. It asks you for your language. English is the default, so we'll press OK. Are we in the US, and do we require daylight savings time? Yes. Time, set hours, minutes, and seconds. Date, day and month. Year, enter. Or OK, I'm sorry. Application. Which application are we going to use? Excuse me. A standard, which is a normal analog input 1 for speed reference, digital input 1 for start stop, digital output 1, or relay output 1 for for a status of the drive, and analog output 1 for feedback. Okay. The drive doesn't know whether there's a bypass connected to it or not, so we do have to tell the drive that there is or there is not a bypass. The rest of the information comes directly from the nameplate on the motor. Okay? It's going to ask for the current on the motor in amps, okay? The nominal voltage on the motor, motor frequency, speed, RPM, minimum frequency that you want the drive to operate at. Now this is going to come from a specification provided to you. Maximum frequency. Acceleration time and deceleration time are not tricky, but they're something that requires a little bit of thought in advance. If this is a standalone drive, then the default of 60 seconds is going to be sufficient. If you're working with an automation system, we really need to know what the response time of the PID loops in the automation system is. We don't want to set the drive up to respond slower than the controlling system's PID loop. So I generally recommend that you set the drive up on its accel time and its decel time at about half of what the automation system is expecting to see in its PID. So we'll input an acceleration and deceleration time. Now we have to do a little bit more thought in that, how do we want to handle the drive's operation? Okay? When we're in hand, do we want to be able to start the drive only from the keypad, or do we want to be able to start the drive remotely? So we'll select, in this case, since we're going to go put the drive in hand mode, we're probably going to want to start the drive in hand as well from the keypad. Okay? When we're in auto mode, how do we want to start the drive? Okay, well, we're probably going to want to do that through the I/O terminals on the drive. That's what part of the automation system's job. Okay. When we're in hand, how do we want to control the speed of the drive? Well, it's in hand, we're there. We're probably going to sit there and adjust the speed ourselves to something that makes sense for the system that we're controlling. In auto, again, we'll select one of the analog inputs to control the speed of the drive. And that's it. We're ready to go. Just that simple. Now, obviously, there are other parameters that if we need to do things like enable the drive to catch a spinning load, injection braking, DC braking, all those have other parameters. They're outlined in the manual. We also have guys at Johnson Tech Support, 1-800-ASK-JNSN, if you need any help setting these up. But please, these are much, much simpler. If you've worked with any of our previous generation drives, they could be a little bit awkward, shall we say, to get through the menus. These are much, much easier to set up, so don't be afraid of these drives.
How long have these been out? How long have you been out?
We've been selling them now for about 4 months. They've been on the market for just about 2 years. So they've got a good track record so far. It's a great product, and we're looking forward to seeing these really out there a lot more and a lot less on the current gen drives.
And these actually sit on the SA bus.
They will.
PC controllers, right?
They sure will sit on the SA bus. They've got N2 communications available to them. I believe they're also still going to offer the old XT card. I have to verify that for sure, but I don't see much call for that. So, all right, that's it. Any other questions? Okay.
All right, awesome. Thank you very much.
If you need to control it or measure it, Stromquist & Company has a control solution for you. With over $2 million of inventory between our Georgia and Florida locations, an easy-to-use online ordering platform, same-day shipping, and a factory-trained team of controls experts to answer your questions, Stromquist & Company continues in its tradition of offering great service and great products.